Okay, so in this video, let's understand what the log loss is. So log loss is basically given by this formula. It's given by minus 1 by n, where n is your number of data points. Summation I equals 1 to n yi into log of pi plus 1 minus yi into log of 1 minus pi. Okay? Yeah, this is the summation for the entire thing. So I know this looks big and scary, but I'll just break it down for you. Let's say I have data points x1, x2, x3, x4, and their class labels are y1100. Okay. Now, before I forgot to mention something that log loss is used for binary and multi-class classification only. Classification, right? That's what it's used for. And let's say that instead of giving me an output for a class, my model gives me a probability value as an output. Let's say it's 0.9, 0.9, 0.1, and 0.4. So how am I deciding the class for my data points? If my probability value is greater than 0.5, I give that data point the class 1. If my probability value is less than 0.5, I give my data point the class 0. Okay, this is y hat, which is predicted. This is y, which is the actual class class label for each data point. Okay, this is actual, and this is y hat. This is predicted. Okay, so that is it. So now let's put this in the formula. So I'll take 1 by n away because it's constant, and n is the total number of data points over here. So I'll take 1 by n away, and so basically, if I find the value of log loss for x1 for the data point x1, I'll get yi, which is 1 into log of 0.9 plus 1 minus 1 into log of 1 minus 0.9. Okay, so this goes to 0 because it's 1 minus 1 into log of 1 minus 0.9. This is 0. And over here, I get the value of log of 0.9 as 0.0457. Okay, let's take x3 now because x2 is also 0.9, so it'll be the same value. X3 is 1, sorry, it's 0. 0 into log of 0 is my actual class label. 0 into log of mm, log of 0.1 plus 1 minus 0 into log of 1 minus 0.1. Okay, so over here I again get the value as log of 0.9, which is equal to 0.0457. And then I have x4, which is 0 into log of 0.4 plus 1 minus 0 into log of 1 minus 0.4, which is 1 into log of 0.6, which is equal to 0.22. I calculated these values before starting the video, so that's how I know them. So ultimately, you're going to add all these values. You get 0.0457 into 2 plus 0.22, right? Now, if you notice something, you'll notice that the more extreme the values are, if I take something like 0.1 or zero point 0.9, which is closer to 0 and 1, I get a very low value for log loss. If I take something towards the middle, which is 0 0.4, my value for log loss increases drastically. It went from 0.0457 to 0.22, which is a very big difference. So it's easy to see that log loss penalizes for the value of your model, the output of your model, if it's not extreme. If the model is not sure if it's giving you the value somewhere towards the middle, to somewhere towards zero point 0.5, like 0.45, 0.48, 0.61, the model will penalize that output and give it a very high value of log loss. On the other hand, if you're getting very extreme values, if the model is very sure about its prediction, you will get a very low value for log loss. So ultimately, you have to add all of it and multiply it by -1 by n, right? So it's easy to see that the value of log loss, the total value of log loss, is a negative number. And how do you know if your log loss is performing well? Well, the more negative the value of your log loss, the better it is. So the smaller the value of log loss, or the more negative means smaller. The smaller the value of log loss, the better the model performs. Okay, so that is log loss for you. Now, this was binary classification, right? How do you change the value of log loss for multi-class classification? It's easy. It's just you just have to modify the formula a little bit. For multi-class classification, the formula is given by I equals 1 to n summation j equals 1 to c. I'm considering that there are C classes. So from class 1, class 2, all the way to class C, I have Yij log of Pij. Okay. Yij is Yij is the it is basically what I'm saying is my ith data point, the ith data point belongs to J class, right? And log of Pij is again the probability of that the ith data point belongs to the jth class. P of ij is probability that ith data point belongs to J class, right? So this is log loss for you. And yeah, I'll stop the video here.